Just a brief disclaimer. I think all the views and opinions and ideas expressed are solely my own and do not reflect any ways my employer or any previous organizations, right? But before I jump into the session, I would just like a raise of hands as to know how many of you have, a brief understanding about big data or data engineering in general. Okay, good enough. Thank you. Okay, we have a few more people coming in. So just to give a very, I'll take 2 minutes, just to give a very brief idea about what Databricks or Apache Spark looks like in a big data environment. Very similar to the databases you access, and they follow a particular algorithmic approach to run a particular sequence using indexes. Very similarly, in the world of big data, you have kind of these jobs running because we are talking about distributed systems where a particular action you have different big data either on your S3 or different blob storage, and you want to do parallel execution on those data. So what Spark does is it creates a sequence or a parallelization of jobs. Each job again gets separated into stages. These stages again are distributed into tasks. So what you have is a core systems, a CPU which has 4 cores. So you have 4 tasks running on those. That's how it distributes, manages, and orchestrates it. There's a very simple example of what a query looks like. So let's say if you have a SQL statement to join, let's say, a couple of candies with different colors, and you want to group them and want to get how many candies of each count for each color you have. So that could be done very easily on a single machine, but when you take it kind of, let's say, billions of records, we cannot do it on a single CPU. That's where Spark, what it does is it divides this particular query into different stages, and each stage again is distributed into tasks. And that is again depends upon whether that particular task has all the data it needs to execute it. Once that task completes it, the stage then again accumulates all the results from all of those tasks assigned to it, and then proceeds to the next stage. So that is just a brief idea I wanted to give as to what happens in Apache Spark in the big data engineering line. The key aspect is if you have worked with different systems, particularly Databricks, because most of the big data work is done in Apache Spark, Databricks is kind of the company which creates the managed interface for you so that you don't have to manage the machines. You just have to work on that interface. We all know about ChatGPT and all very relevant interfaces which give us additional information related to any contextual information we ask for. And big data being a bit of challenging because it has a lot of aspects, a lot of technicalities in terms of maintaining a distributed environment. Very similar to what you have in databases, like doing an explain, understanding where your query is spending most of your time. Very similarly, there are different aspects because when you're running your queries or your jobs, processing a lot of data, you have to understand whether that data fits into that task memory. Because a CPU might only have, let's say, 1 GB of memory, but your task needs kind of 2 GB of data, so it spills over. It's kind of out of memory. So there are a lot of concepts involved when you're writing Databricks jobs. So Databricks have come with an assistant called Databricks AI Assistant, which you can open, and you can see on the right, there is a area here where you can ask any question, and it can give you very contextual information based on the documentation of Apache Spark and Databricks in particular. The key aspect is that it does not have context into what you are actually running. So it can give you, let's say you're running a notebook, it knows what is there in memory, but let's say I want to run a very long-running job. And in particular, there could be a lot of issues. Let's say memory spill, there's a skew, there's a hot data center, a lot of areas. And one particular query you can ask Databricks AI assistant is, can you help me directly find out the problem? Because there could be n number of problems. Finding the solution is easier, but finding what is the particular problem here is the very first task data engineers face. So they have to look into the Databricks AI I'll talk about it. So Spark EOI is what is kind of the log interface for the Apache Spark. And once your job runs, you have this interface to explore out where your job is spending most of its time, how much memory it is taking, and each has its particular step in terms of finding your exact issue. And it's not a very straightforward answer because it could be relevant to your data, it could be relevant to your cluster, it could be relevant to the configuration you have set up in the Databricks. And with an approximation, with my experience seeing and working with different colleagues, it can take sometimes from 3 to 5 hours just to find and go through the plethora of information present here. Now here you can see it's a particular job, and there are 2 executors. The executor driver has been added, and it's the event timeline. Here you can see additional executors are added. On the right, if you see again, 4 executors have been removed. And this could be due to a variety of reasons. Maybe you have enabled auto-scaling in your configuration, or maybe these machines are actually failing, and that's why they are being removed. This is one example which says that there are 258 tasks, so a lot of tasks for a particular stage. And if you see, this is another profiled input, where it says that there's no spill of memory, but there's spill to disk of around 1 GB. And this is another where you can say there's not any spill or skew, but there's a lot of input and output. So it's reading a lot of data from S3. So that's where it's spending most of its time. Now, one of the questions is, let's say you're running a very simple job, and it runs for 5 hours. And we don't know why it is taking so much time, because it could be a lot of different stuff. And based on your organization, there could be different levels of data engineers who might be working on this problem. And they might not have all the experience related to what is a skew, spill, and right now some of these terms I'm speaking might not be very clear to all of you, right? So understanding this is the current solution availability is there's an optimization solution. There could be configuration changes or format changes based on, let's say, if you're just reading JSON data or CSV data, which could be a bit imperformant. But you can convert that to Delta format, which could help you, get some more performance benefits out of it. Now, what Databricks has, or Apache Spark has shared, is that they have shared a complete list with us, that this is the guideline you have to follow. First, check the timeline, then go into the stages, then see if there is a spill of memory, and after that, check how many tasks are being executed. So a lot of steps, but they are in a very particular line of action. So if you follow along, if you understand them, you can go through that. But I think if you suggest that to one of your data engineers, okay, please follow this document and then understand it, it will take at least, I think, the 2 hours to read the document, the next 3 hours to figure it out, because you have to follow, okay, I follow the document, I come back to my view. So there's a to and fro motion there. And the core challenges is lots of lines of logs which are being generated. And the root cause analysis takes a lot of time. there are documentations existing, but they're not very correlated to the Databricks AI assistant at this current point. This is one job which I ran in my local system. And if you see, it just generated a single file. This is all the information which the Spark UI takes just to show you this information. So a single file has all these event data which is being shown. So there are two parts to it. First is the events, which is very specific to your organization, specific to your data and the process you're running. The second part is relevant to the Spark UI, because Spark UI basically takes this information and shows you in this organized manner. This is kind of the format in which the log looks like. So it's kind of, in each line you can see there's a JSON statement. So it's kind of the JSON-L format. And each of this gives you particular information. Now, if you think about this information, one of the ideas we can think about is, when we think about it's a sequence of events which we are trying to figure out. And each information is related to the next, like a job is related to a number of stages. A stage is related to tasks. A task has particular configuration, certain memory, which it runs on, plus the configuration of your cluster. Now, when you think about this, it's a very sequential action. You have to understand a few concepts here. What is the spill? What is the skew? What is the memory I/O? If you think about, these are very understandable from a machine perspective. A large language model can understand this data very easily because it is in textual format here. And this is where one of the steps here is, first we configure in Databricks, where whenever you run a Databricks job, where does this event log is stored? So we configure it to store it in AWS S3. And we mount it into, it's kind of, you're mounting a particular file location so that the logs are generated in this location here. And this is one thing which we talked about, that is a single application starts with a single log file. Sometimes it can be multiple log files. This is one starting prompt which we can look at, where we are saying that follow these particular 5 steps, and these are very exactly what Databricks document says to you to do manually. So this is what a example looks like, plus a few short examples. So I share with it a particular log, and I also give it what it looks like to parse it, so that it has some understanding of it. There's a very starting architecture if you think about. So in the top you have the configuration setup. And here we are using OpenSearch. So the ingestion pipeline, whenever a new file is generated, because this could be automated, whenever anyone in your organization runs a particular job, AWS Lambda ingests it into your OpenSearch. And based on that, you can write a prompt query, which we just did show, and get a response from it. With this, what has happened, that the output is not that clarified, because if you see from the previous document, it consisted of a lot of steps and a lot of numbers and calculations. The second approach could be, we can think about to ask it, think through it, kind of a chain of thought process, to further spend time on it. The results have been a bit more promising to start with, but not into the very detailed level. The second part, if you see about it, the very first sequence we saw, that is the jobs, stages, and tasks. If we think about it, it is a relation, right? A particular job is related to 3 stages. Each stage is then related to particular tasks. So it's kind of, we can represent this data into a graph database. So this is where we are parsing the relationship and storing it into a graph database, which can use a Cipher language like Neo4j. Now, using the prompt, what we are now, at the very first step we are doing, is fetching the result from the relationship first, so that we understand what is the first step, that is to fetch the stage. From the stage, we get all the information and also parse it to because we also have the logs in our OpenSearch vector store. So these two information, when we search it, that is the very first subtask we are solving here. Once we have that, we ask the large language model to go a step deeper there. So this is how, based on a relationship model, along with your contextual search, we are further solving it in a step manner. The third part to it, if you understand about it, we are not only looking into finding the problem statement here, but also how we can solve it. This is, if you see on the left side, we have another pipeline which runs, which stores the solution documents. Because when you go into the documentation page of Databricks or Apache Spark, for each problem, they also tell you what could be the solution, how to approach it, what is the configuration you can change. And all of this, if you think, is very contextual. As a human being, I need to remember what my configuration is, which cluster I'm using, and what I can update it to. So that's a very huge contextual information for me. This is where a large language model and the contextual information generated by OpenSearch can really help me and the LLM, because now not only it has generated a problem statement, but for that problem statement, there is a solution in the documentation. So here you can see there are two steps, and the major task here is the first one, which is finding the problem statement, which we are solving here. There is the third part, where along finding the solution, let's say you want to find out what is the approximate or the threshold partition value, which needs to be set for each of your tasks. And that is a calculation which needs to be done, for which you need a Python interface. So that is where the agentic tool interface will use it to calculate it. So here, if you see, we have the solution documents, we have the event logs which are being passed, and the third step, we also have the tooling interface, which calculates the number for us to give us the exact partitioning number. Now, we all know that agentic tool right now has been spreading in different ways in particular. Like, because we don't not only want the answer, we exactly want to run it across also. Because we want to verify whether that answer is correct. What I can do is I can get that answer from the large language model, then execute it on my own. It could consist of some error, right? Because there are probabilities of it failing. So it's all about trying it. And if you think about trying it, it will take me again 3 hours to run it. How about I add a Databricks tooling layer, which allows the large language model to execute this on its own, so that I don't have to run it manually. Maybe it has 3 solutions, which it can run parallelly, and generate that perfect solution for me. The side effect for it is that Databricks costs a lot, because it's running on huge machines. We don't have that much cost. Where we can add a beneficial layer here is the law of scalability. So when you have a huge amount of data that scales to a particular timeline, when you reduce that data set to a smaller level, you can scale your time accordingly to a lesser level. So this is where we generate synthetic data from your production or your test data to create very similar data set. But your Databricks now runs on this very small data set. And you compare the timeline using the law of scalability here, so that you're matching along those expectations. So this has kind of a trade-off here, because you're trying to run your Databricks tool in parallel to generate those solutions, which would be very helpful for you. The other approach on top of this, which was also very helpful, is if we saw in the previous, there was a single agent which was doing it. But if you think about, we had 5 stages, 5 problem sets, which each agent can do on a subtask level. This is where we are dividing the tasks among smaller agents, which run in parallel. And finally, a single agent collects all of these feedback together. And this is where, if you can think about, there's a parent agent, and there are 3 levels of agents here. The very first one works on the staging level, after which it works on the job, then the stage, and the task. So at any point when the agent finds that there's already a solution, we don't need to move to the next stage, it just cuts it off at that point. Now this feedback is given back to the parent agent, which can give you the response back in time. This is one of the outputs by the large language model, which was experimented upon. So if you see this, using the logs, event logs, it had this initial information. There's a shuffled read and a shuffled write of around 6.4 GB of data. And it knows what is my worker configuration. All of this information is already present in the event logs, because that is your cluster information. From here, what it is doing is it is taking step-by-step actions. The very first is it's telling that your total amount of shuffled data is around 6.4 GB. And now it says setting the target size per partition. It's taking these inputs based on some optimal information, which is 128 MB per partition, which is a configuration which Databricks and Apache Spark suggest to work with. And if you think about it, it says that the number of partitions should be based on total shuffled data by target size per partition, which results in 50. So for this calculation in particular, it went to Python to calculate it, fetched it back using the tooling callback interface, and finally adjusting for the parallelism. This is where it gives you what should be the number of partitions which should be used for your configuration. And this is the recommendation it has for you. So you need to set this configuration of Spark SQL shuffle partitions of the value 80. If we think about this, these are the steps which the overall system followed, which is loading the Spark UI checklist, queries the longest stage, which detects the skew, spill, or the I/O bound. We are also retrieving documentation information for explanation of what could be done. It suggests the remediation as to what needs to be done. And in the final, it gives us the summary back for future reuse. If we think about the results from this whole experimentation, the first one is that the quick find out of the actual problem at hand. That is the only step which stops data engineers from finding the solution, because they don't know what is the exact problem at hand. You need a more experienced engineer here. We are talking about democratization of data, of AI, but I think this leads to a democratization of operational efficiency. How can a large language model through an ecosystem of tooling can help us here? And if we focus upon the last 2 points, this is, I think, it leads to a data engineering productivity of 2x, because if you think about it, we really should know about what the problem is. That is our key insight. If you talk to any one of our colleagues, okay, what is the problem? That is the first question they'll ask. And if we say we are not sure about what the problem could be, that's a different expect here. So I think that really reduces the time to find the problem, and we can focus upon the solution. And the time to reduction to debug to finding the problem is reduced from around 5 to 8 hours to around 5 to 15 minutes. So that's kind of a very huge amount of, in terms of where an engineer spends their time on. This is a brief introduction, just some information about me. So on the books which I've written, there's also one coming on generative AI driven, but very particular to Java, not on Python, which we all think about. So the ecosystem around Java is also evolving. And there's a one-time discount code for all attendees here, around 20% for the books. Thank you. Any questions for me?
Satej, any questions, anyone? I did not see the hands.
So I just wanted to understand whether at least it was conceptually understandable in terms of where I'm coming from. And for those who are not too deep into what data engineering is about, where it comes from and how does it help. So I think, yeah. Okay. Yeah.
I'm just wondering, what kind of suggestions your LLM will give you for optimizing the workflow, apart from specifying the number of partitions.
If you think about the large language model, we have in particular given it a prompt as to what the Databricks documentation has followed. The current Databricks documentation gives you instructions. First is to visit the event timeline, see how long the processes are. If you don't have long processes, then go a step deeper, go into the stage level, find out where it is spending most of its time on, right? And a large language model kind of follows these instructions. We could further develop it, because always there is room for improvement. This particular prompt is limited to what Databricks documentation has suggested, but based on different workflows, because not only it is about, it doesn't understand my data right now. It understood the events, but the events don't have my data. If we give it some more contextual information about the data, what is the process we are following, because that could also be a query from the user end as to what it is trying to do. So all of this could also particularly give more insight to the large language model to give me more solution along this way.
Any more questions, anyone? If not, then I will go for my question.
Sure.
So in the architecture diagram, you also had OpenSearch somewhere, right?
Yeah.
So what is the content that is stored and when is it stored, and how do you use it in this entire workflow?
So I think two kinds of information are stored here. The very first one is the event log. Because the event log, if you think about it, it contains a lot of information. And if you saw about the Spark UI, all those information is stored there. So if you think about this particular interface here, so this is what all this information is coming from, like the logs which I did show. So there's the application, you go deeper into it, if you see a lot of logs here. Now if you can think about a particular data engineer as to what he would have to go through, he or she would have to go through by seeing all this information. So they start from the bottom, they go up, they see where it is spending time, okay, these tasks have succeeded, to check for failures and all this information. And Spark UI just getting this data and showing you in this format here. Now what happens here in particular is that we are collecting all this log information in OpenSearch. so that we can get it in a RAG flow, because there are two combinations here. We are using RAG. We are also using the graph relation to find out particularly which contextual information we want to search. Because when we are storing this information and context in the OpenSearch vector, we are also storing metadata from the relational data because we want to correlate it as to which job is correlated to this in particular, so that we can also get more contextual information when we are searching it and when we are trying to map the RAG plus the tooling layer. So that is the first. Our event logs only contain information about our data, but not the solution. So this solution is also important because I need to, once I find the problem statement, which solution is relevant to that problem. That is where, if you see on the left here, we have the solution documents which are also being fed into OpenSearch. So that is another query which we perform once we find the problem statement here. So those are the two data points which we are storing in the OpenSearch vector.
Okay. Any questions? You had a question? Yeah? No? Okay. So maybe then, because we have time, I have another follow-up question.
Yeah.
So to the LLM, the prompt that you have,
yes.
So you send also the relevant or the corresponding logs to the LLM?
Yes. Yes.
And it has the prompt, so it is able to provide you a contextual answer?
Yes. Yeah.
Okay, that makes a lot of sense. So which also means that this solution is not restricted to just this Databricks thing, right? It's basically let's say any other big data system.
Yep.
If you already have an SOP,
yep,
right, you can use it as a prompt, store the logs in it, and do a very similar agentic approach.
Yes.
Right.
So I think this approach can be fitted to any structure. The only thing is different. Let's say you have Dremio, which is another open source engine, very similar to Apache Spark. Each have their own ways of functioning. There are a few common levels of understanding, like partitioning, big data, and all this. These concepts are very similar, but some are very particular to how these engines work internally. So I think those contextual really matter, and those can be very easily switched if you are using different engines in particular.
Okay, thank you.
Yeah.
A round of applause, please.
Thank you so much.